Hi, my name is Jack Lepausch, and I'm a software engineer at Two Sigma.
Hi, I'm Sam Srinivas. I'm a product management director in GCP, and I work on security topics.
And we're here to present Two Sigma implementing Fintech security in the cloud. So to begin with, what is Two Sigma? We're a technology-driven investment manager that uses data science to derive insights that forecast the future and uncover value in the markets worldwide. And we do so using technologies like AI and ML and a lot, and I repeat, a lot of distributed computing. For that, we have for this topic, what we want to emphasize is the fact that we have very, very high value IP. That is probably one of the more important points for us, because unlike a lot of companies, unlike maybe some of you guys, if we have a breach, it's not just a little problem, it's a big problem, because if anyone else has our IP or we don't have our IP, we can't exactly go forward. Right. So what is our problem in that sense then? So we want to strike the right balance between security and access. So on one hand, we want a secure environment where we can protect ourselves from external and internal threats. But at the same time, we don't want to block our developers, our modelers, our stakeholders in general from accessing that data. And who are those stakeholders? We actually have quite a large number of them. We have our internal users, which are the people inside Two Sigma that process a lot of data and run models on them, and this is internal data. And on the converse side of that, we have our external users, which also process a large amount of data, but in this case, it's external data to Two Sigma. And under them, we have these modelers that take that data and create models and implement them. And over that, we also have this community, which are people that use our products that aren't directly connected to us. For instance, we have this game called Haylight, which is our artificial intelligence challenge, that has thousands and thousands of users from across the globe running arbitrary code, and we have them as stakeholders as well. And under all of that, we have our internal developers that build the tools for all of these people to use. And of course, we also have our security team that also want to build secure tools on top of the cloud and that want to keep that cloud protected using least privilege. So what are we going to do today? Today, we're going to talk to you step by step how to build your own security on GCP that somewhat mimics what we have, a simulacrum of what we have. And we're going to start from scratch and build it slowly and build it easily in a very abstract and easy to understand way, such that you can benefit from our hindsight. In what way? Well, as we built things from scratch, we had our problems, and we followed some paths that really led nowhere, and we had to go back, and we had to redo, and that took time. But right now, we're going to walk you through the exact path in the right way so you can do it the right way the first time. And I also want to emphasize again, this isn't exactly how it looks like internally to us, but it's close enough that it can be abstracted to all of you. And so to start with, or to end with, this is what you're going to have when all is well and done. Of course, don't be scared by that. We're going to walk you step by step from the beginning how to get to this complex image right now, and Sam's going to take over and talk you through that.
Thank you, Jack. So as Jack said, you saw the complex diagram just before this. We're going to start from scratch and build layer by layer as to get there. And each point, you will have an understanding of why we did that. And you can follow that as a kind of a high-level roadmap. You could follow each level. We'll talk about what threats we were considering, and you might follow the same thing when setting up an environment from scratch. So here is something where there is nothing. Two Sigma has just come onto GCP. Their super admins have just signed up, so obviously need some kind of admin to set things up, and they've set up an organization. Nothing's been set up yet. And on the side, obviously, they have their existing on-prem data center, and that has some kind of local computing already, their servers which have existed. And very importantly, it has the root of all their identity, which is Active Directory, which is where all their employees and perhaps contractors and so on are. So the very first step, basically, is to connect up the identities from their Active Directory onto the Google Cloud setup. So what here you're doing is to ensure that in Google Cloud Platform, when you're writing an IAM rule, every developer, every Joe, every Alice is available with their group settings. And to do that, Two Sigma use something which we call a tool which is available called GCDS. It's Google Cloud Directory Sync. It works with Active Directory and synchronizes all your user and group information onto the Google Cloud. And going a step further, at this point, you could actually, if you were doing this, you could say, well, that's great. Now I would like to use Google as a primary login to my system. So in other words, you go to the Google login page, your developer logs in, and now they're ready to set up a VM or whatever it might be. But you have another choice, and that's the choice which Two Sigma made. Two Sigma was using an Active Directory as their SSO, and they chose to stick with Active Directory as SSO for reasons which Jacques will come back later in their use case. It was important. And that, again, is possible to set up. You have the Google login system can run headless, so to speak, and instead can federate onto Active Directory, which is set up with the SAML. And so the user experience would be, for a developer, you see the familiar Active Directory web login, and then you actually are now logged into Google, and you can be ready to set up resources. Now, setting up resources, let's talk about what that is. So obviously, the only reason you're on the cloud is to have computing and data and so on. So here, basically, there are three canonical examples we have in this abstract diagram, and these actually very much apply to obviously what Two Sigma really did. They have a bunch of Linux VMs, and the Linux VMs actually embody the custom IP which Jacques was talking about. So they might be doing some custom modeling, a very high-value IP, and they're running models and so forth. There's an App Engine application, and the App Engine application is the control for this. So in other words, if I'm a developer or an external modeler, one of the user types he talked about, you would see a web interface, you would do various things in it, and at the back, you'd be running the models on these Linux VMs. And of course, data is stored in cloud storage. So the first step, again, we're doing this systematically. So you'd say, create these resources at this point. And we haven't yet set them up to be locked down securely. And what's the first step to be taken? What did Two Sigma do to lock them down? The very first step is obviously to use IAM. So all security really, as you can, and I think it's a fair thing to say, is about controlling who can access what. And the first step is to say that App Engine setup can only be manipulated by our DevOps group. And similarly, something similar for the Linux VMs, maybe it's some other group, or maybe it's DevOps, and similarly for the cloud storage access policy. So when you set these up, what that means is that obviously locking down in a very big way, you can't, for example, I could be logged in as some Gmail account and I can't access this anymore. And however, at this point, I'll just make a point that somebody in the DevOps group can maintain that App Engine or change the settings, IAM settings or whatever it might be, or use APIs against App Engine. They could do it from their office, but they could do it from anywhere, and just hold that thought in your mind. So at this point, we have locked down these resources with basic IAM. So I'll give it back to Jacques to tell us what we've done so far.
So what did we do? We set up GCP using our super admin account. We synced our user identities using AD, and now we can really we have that direct connectivity there. And we set up our first resources. We now have VMs, we have buckets, and we have the raw access control rules for them. But not everything is perfect right now. Now we have some concerns. We set everything up using the super admin, and he has very, very large powers. So how can you make sure that that can't be compromised, that a third party can't gain access to that and do evil things, or if the super admin can't do something by mistake? We do have all those resources, and they are accessible by Two Sigma, but they're also accessible outside Two Sigma. And that isn't necessarily something we want. We want something that our developers can use, but not elsewhere. And again, all resources now can be accessed everywhere. We don't really have any block, any firewall, anything prohibiting them from using it elsewhere. And finally, our developers want to use Kerberos. They want to sign into things directly using it. And we currently don't really have a way to sync that through our AD. So Sam will tell us how to resolve those issues.
So the first point Jacques made was the super admin privilege is pretty scary, because this is like a God privilege, and you always need that. You're setting up your cloud, you're always going to have some foundational account which has set up. You want to reduce it to as few as possible, but you're still going to have something. And that's not going to be necessarily on your SSO, because this is essentially a bootstrap account. So how can we make that more secure? So the big concern you have with account security is phishing. And so if you have, of course, you might put a password. Obviously, as a password, you might put an OTP on this. That's very good progress, but for something which could potentially shut down your production systems or whatever, that's the kind of privileges this admin has, we want to lock down further. And what Two Sigma has done is it's used an MFA product called a security key and shut down and locked down the sessions to be very short. And let me tell you a little bit more about security key. So as I said, phishing is the #1 login attack. However sophisticated the user might be, there typically is a very crafted way where when they're not paying attention, you can actually try and phish them for their login credentials. And any what's called a bearer credential, think anything which you can type somewhere, you can be typing in the wrong place. So that obviously applies to passwords, applies to OTPs. Now we're not trying to sell OTPs down the river. OTPs are a huge step up, but for the what's at stake here, we have to go further. And what the security key gives you is essentially a second factor specifically designed to defeat phishing. Now, defeat's a strong word because nothing is perfect, but it inherently has this design. And so how does that work? Your user, let's talk about user experience first. If you use a security key, you're a super admin, you type in login, password, you stick a key into a USB port and press a button. What's happening behind the covers on the server side when it verifies the second factor are two things. Firstly, each of these keys is a crypto key. It has a private key tied only to the account. So of course, it verifies that, hey, is a signature from this particular the account, which is a key which is attached to this account. Secondly, the signature area, what is within the signed boundary, also has what the URL that the browser is seeing in actually where you type over there, basically the ETLD. That's a pretty key thing. Effectively, the server can see where did you type in the login and password? Did you type it at google.com or faked google.com? And in effect, that is what prevents the phishing angle. And so it's a very significant upgrade to security. And so the foundational superadmin logins are locked down this way.
And you also get one really nice bonus from this, and it's an unwarranted bonus from the key. But basically now, you can have multi-party auth. The idea is if you can share your password with one party and you can share the key with another party, suddenly you can make sure that anytime someone logs into that account, it needs to have both of those people in. Kind of like in those old movies where two people had to turn the key to launch the launches. Yeah.
Yeah. In fact, that's a very interesting use which Two Sigma made, which typically you might say, that's great and all, this super admin, make it even more secure. I don't want just a Joe or Alice to have power to do this. They might go rogue on me or they might make a mistake. They've effectively used this feature to separate out the privileges. So Joe's got the password and Alice has got the key. And as a minor point, you can actually have multiple keys to an account. So you can have Alice and Jane and Bob, perhaps, if you so choose. So any two of them kind of thing. So going back to what Jack had said, he said, well, there are various things wrong which I want to improve. One thing was locking down the admin account. The next thing which he pointed out was, initially we set up for example, the app engine to be accessed only by DevOps, but you can also have that app engine instance to be accessed or controlled by any identity in Google. That's a feature, not a bug. For example, in your case, you might say, we want this contractor or that company which we have a deal with to be able to control our resources. However, in their case, they want to have a lockdown. They want to ensure that these resources cannot be even accidentally have allowed access to anybody other than an identity from Two Sigma. And so here again, they enable something which what we call an org-wide policy. So you go to your organization, the container in which all your resources live, and you can put a policy which essentially says, in plain English, allow only Two Sigma entities to be having control on these. And so what that really does is basically prevent any kind of inadvertent mistake. So for example, someone in a project, a junior engineer in a project, he or she might have a bright idea to just share some data directly with an external contractor with all good intention, but this is essentially prevents that. So there are other org-wide policies too, which Two Sigma chose to use. And again, these might work or might be useful for you also. And in their case, for example, they set up a policy where a VM image which is used in one project cannot be shared with another project. And Jacques, maybe you can tell us a little bit about the motivation here.
So this is an issue for which we were pioneers in. We found out firsthand that Google had added a specific feature that allowed you to move images from within projects, which is actually quite a useful feature because in a lot of cases you do want to do that. For us, however, that's an exfiltration vector. That means that we can have a very lockdown project and a non-lockdown project within the same org. And suddenly we can copy that image that has all our private IP to the other project and then take everything out. And we came to Google with that problem and we said, we don't necessarily want that. And Google came around and made us this specific org to help us to specifically block that, which is a great boon to Google's.
Yeah, so like Jacques said, in their case, they have multiple kinds of stakeholders, end users, and there may be different policies relevant to each, and this prevents the information sharing at the very image level. So going on to one more, again, the theme here being org-wide controls. You set them up at the organizational level. One of the controls they chose to set up is that they allow no serial port access to VMs. Now, serial port access to VMs, again, is a feature. It might be, in your case, you might want to allow that, but in their case, they did not. And just to recap, you bring up a VM. If it's on the network, you can SSH to it, but then there might be some network configuration issue. It might not be accessible. The serial port is the sub-network. You're accessing it, in quotes, directly, and that's what we allow. But in their case, they chose not to allow that, and Jacques, maybe you can tell us what drove that.
Sure. So again, that access is unrestricted. It is useful. If you have a network, if you have a machine that's breaking and you can't get through the network and you configured something wrong somewhere and you really have to get to that VM, this is the way to do it. And it's useful, but again, for us, that's an exfiltration vector. It means somebody can forgo all of the network rules and just go directly into your project, into your VM, and take everything out, as long as they know the password, which I'm sure malicious people can get. So we wanted to block that.
So let's take a little bit of a stock of where we are. So we have set up an integrated set of policies. Every one of those yellow lines that you see, it represents basically policy which you saw us setting up. So at the App Engine instance, the Compute Engine instances, the cloud storage, we set up policies at the group level, as you remember. The super admins are locked down so that they can only have a phishing-resistant login and with short sessions. The admin uses identity effectively. They are delegated down from Active Directory, and that's the policy. And the box around a Two Sigma organization, if you remember, we set policies saying that you can't share any resources from outside, you can't copy images, you can't lock down a serial port, and so forth. So let's take some stock here, and I'll give that back to Jacques now.
So we now lock down our superadmin login. Superadmins now don't have godlike powers. We now didn't allow resources to be shared outside to Sigma identities. So people outside to Sigma really can't access anything yet. But we still haven't solved everything. Resources can still be accessed from anywhere, and we still don't have our much desired Kerberos for our devs. And Sam's going to walk us through how we get that.
So network layer control, as all of us know, we want multiple layers of access controls. And one conservative and obvious access control mechanism is to put a network boundary around a set of resources and make sure they cannot be accessed from anywhere but there. So that's called a VPC. And in this slide, we show the first step of a VPC, which is around the Linux VMs. And there, it's what you would It's the classic network construct. You have a bunch of Linux machines, and you put basically a firewall around them, and they cannot open a TCP connection or SSH or whatever, SCP out from the boundary. And similarly, they have private IPs. They can't be accessed from the outside. That's interesting, but we want to bring that notion of VPC not just to just a translation of the physical past, but also to these virtual constructs or these cloud constructs, which is the App Engine and the cloud storage. And how do we do that? So what is the mechanism for doing so? And so essentially, we want to say these things cannot be accessed from the outside. So there, again, as you can imagine, it's in the cloud. Everything is policy and config driven. And on the VPC, you set a resource policy to do precisely that. So in effect, here the plain English notion is you can't access data from the outside, from the containing VPC, or from outside the containing VPC. And what that really means is that that App Engine instance, the cloud storage instance, now their management or the access to the APIs, if you remember before, they were locked down to the DevOps group or whatever. The DevOps group can no longer do it from anywhere on the internet. They can only do it if their source IP or they're within the private network. So we in effect bringing these abstractions which Google's providing you also within the notion of a network boundary. So having said that, the next step we do is this VPC obviously is like what you would expect. It is a private network, and you connect it up to your on-prem. And what Two Sigma chose to do is there are multiple options. You can use either a site-to-site VPN or something called a private interconnect. And they chose to use a private interconnect, and that gives them some amazing speeds, a 60 gigabit connection. So in this context, we're talking about a security, but it's also really, really fast. So the connection, once you connect it up to your on-premise, your VPC, which is on the cloud, that brings us to the solution for the fourth problem, which Jacques talked about, which is basically that the developers were used before when on-prem. If you see the local compute on the on-prem, they were used to getting a Kerberos ticket from Active Directory and logging into their Linux machines on-prem. They want the exact same thing basically on the virtual machines which are now on cloud. And this, when you hook up the network this way, you have the private connectivity, and the Kerberos ticket now can travel over the network, and so you can get Kerberos access to the VMs. And so that basically gets us to where the list of questions we had, and I'll give this back to Jacques here.
So as we talked about before, we had already solved 1 and 2, so onto 3 and 4. We now have the VPC, so now data can't be easily exfiltrated from that. And we enabled Kerberos, so now our developers can just sign into things directly without all that hassle. But we're still not 100% there yet. So a bad insider can't copy the data out of the network. We locked it down, right? But we only did it directly. What if someone indirectly takes the data, copies it to another GCP resource, and takes it out from that open GCP resource, like a personal bucket? So buckets have encryption by default, which is good, but we have compliance issues, and we need to manage the keys so we can give good compliance visibility. And right now, no resources can be accessed from outside the VPC, but sometimes we want to give access. We want people from the internet to have access to some of our data. So how can we do that securely in a way that doesn't break what we have right now? And Sam's going to talk about that.
Thanks, Jacques. So the first problem which Jacques talked about was, though we set up a VPC boundary, and though it was the case that that App Engine instance now cannot be accessed by Joe in DevOps unless Joe in DevOps is within the VPC network, so to speak. There's still a problem, which is that if Joe goes rogue, in principle, Joe could, or even Joe by making an inadvertent mistake, could set up instance of a personal bucket and could make a copy from the data which is inside the VPC to the personal bucket. In essence, we don't have an outbound, at this point of the build, we don't have an outbound firewall, so to speak, which prevents you from accessing any resource within GCP, a GCP resource, which is not within your VPC. So this is precisely now what we add as a policy. So we add a policy saying, no GCP resources outside my VPC can be accessed from inside the VPC. So you can think of, for example, all cloud buckets in GCP now broken into two sets. One is the sets which are within your VPC as you've designated, and one is everything else. It doesn't matter who owns them. It could be your organization or somebody else. Now, those, even though the API endpoint for obviously cloud storage is accessible, you cannot access those particular resources. And so this cuts out this huge exfiltration vector. And you can think of this as a completion step where you're truly bringing just your cloud resources within your network boundary. This is feature, in case you're looking for it, it's called VPC service control. And there's something which you might want to enable in your setup also. The next point which Jacques talked about was that if you use our storage offerings, by default, all data is encrypted at rest. And we manage the keys, or Google manages the keys. But for visibility or for compliance, in your case, you might say that I want the key management. And luckily, Google provides a feature for that with the Cloud KMS feature. And so what happens is that you set up an instance of Cloud KMS, and in this case was 2 Sigma to manage their KMS keys. And again, it's policy driven. You effectively, in essence, you're setting the cloud storage instances to use keys that you're managing, and that's a policy. So once again, it's software driven, config driven. And so at this point, we have solved the problem of the visibility of our control over the keys, which key management, which Jacques was looking for. And that brings us to the next point which Jacques made. So the only reason you build systems are for access. And in the end, some set of users, you want them to have convenient access, ideally from anywhere and safely. And so here, the end users in their setup could be employees, could be those external modelers and other. Jacques told us about 6 classes of users. How do we enable? You don't want to bring them all inside your production network, obviously, for access. You want to keep them outside, but give them safe access to what you want to publish. And that's precisely what the IAP allows. So IAP stands for Identity Aware Proxy. So it is essentially a reverse proxy front end, which is internet facing for your backend application. If you remember, we talked about this backend app engine application. And as I said, that's a web application written by 2 Sigma to essentially provide a unified front end to all the complex processing happening at the back, model running, and so on. How do you take that application and publish it to the internet in a safe fashion? That's precisely what IAP does. So in this case, you see this named 2sigma.com. They have published an application, 2sigma.com, securely to the internet. When you come to 2sigma.com as a user from the internet, the backend application you're hitting really is this backend app engine application. However, there's a bit more to that. You can essentially write what 2 Sigma has done is use the IAM features of IAP. You can write in policies as to who can access the application. So in this case, we just made up this example. Maybe this 2sigma.com application can be accessed only by the contractors group. Just say so, and what happens is that at every HTTPS request, the actual user logged in is validated by IAP, and if the policy allows, it sends the hit to the backend. If not, it gives you a polite page saying, sorry, you're not allowed access to this resource. The nice thing about this is that the backend app engine application was written with no particular access controls baked into it, because you never know. Tomorrow you might want some other group to access it. So now your infrastructure, which IAPs, enables you to essentially add these access controls right in the front end and provide you just the limited access that you want. So let me give it back to Jack to see where we are now in this journey.
So right now, we made sure that insiders can't misuse the resources to indirectly take data out. We manage the encryption keys to make sure all the storage is compliant and visible. All the keys are compliant and visible. And we published end-user applications safely to the internet so people can now use our services outside. But of course, we do have one last issue. And as my colleague Nick Arvanitis always quotes, if you feel that you're 100% secure and you haven't been broken into, you likely have been broken into and you just don't know about it. So no security is 100% perfect. And for the cases where it actually does go wrong, because things do go wrong, we need to be able to figure out what went wrong, check on it, and fix it later. So for that, we need status and we need forensics. And for that, we have a number of tools. Initially, we have Stackdriver, which gives us the logs that tells us who did what when. Not why, but what and when. We have CSCC, which gives us a console that tells us the consolidated status of everything that we have in our organization. And finally, we have Google's Forseti, the open source tool Forseti, to automate the monitoring and the setting up of policies.
And I guess one thing I should mention for those who don't know is CSCC stands for Cloud Security Command Center. It's essentially intended to be a central console where you get visibility into all your security monitoring. And Forseti is a set of open source tools that we have offered. Look at forseti.org specifically so you can automate setting of and monitoring of policies and in GCP and actually and beyond, actually.
And finally, we come back to our finalized picture of what you should have if you want a secure environment with all the features that Google has. So you're not. So we finally got to that level that we want. We want secure inside, outside, and we have not built any walls for our developers. As the quote often says, build guardrails, not walls. So everything is usable, everything is secure, and we did it simply, step by step, so you guys can follow it. And to sum it up, to Sigma, we're a fintech company with extremely high value IP, like many of you might have. And as I said, we need to lock everything down, but make access easy. And we need a hybrid solution that spans both cloud and on-prem. And by using GCP, we get a control to do so securely, easily, and still use a lot of features. And because of them, we're able to easily stitch all of that together to exact our needs. So Sam will tell us where we can go next.
Yes, so if you saw the core principle in what we were doing, which really applies to cloud, really is that, as I said, controlling access is what security is all about. And so at every point, we were using access controls, identity-driven access controls, to say who can access what. So here, when we say who, it was people things. So this group of people can access this application published out to the internet. This group of people can set this app engine instance, but only if they're in this context, for example, when they're within the VPC and so forth. The next step, essentially, is to. But however, at this stage of the conversation, when Linux VM called another Linux VM, basically it was a TCP connection, maybe it called some API, but that was not a named thing at this point. And so where Two Sigma is, we are having conversations is to take the notion of identity-driven access, not just for human beings, but it's the services themselves, which is, or if I'm sure you've been listening to the keynotes when we talk about Istio and Apigee, that's what it's about. So now, every service actually has a name, and basically and you can set policies which the platform allows you to do, where before you could say only Joe can access the API, and now you can say which services can access what other service. And so everything gets published as APIs, and you essentially have inter-service controls on a service identity-driven basis. And so that's the next stage. So you can just think of kicking the notion of security controls further and further up the stack. Not that the lower layers become obviated by any means. The network layers are extremely important, but they're basically, once you put in they're sort of, if I can use the word, fairly crude at meaning, because they don't have the higher level concepts, and then you basically now focus your security setup more at the identity layers for both individuals and for services. And that's where the conversation is going with Two Sigma, Istio, and Apigee. And they've been a partner for us, actually, in driving many of the controls that we put in, and we look forward to their feedback on the same thing. And similarly, from all of you, please join us on this journey, use what we've got, and then set up all the controls that you have and tell us what's missing. And so help us drive it where it's complete from your perspective. There may be other controls which are not relevant to them, which you might need, which we are not aware of. Let's talk about that.
And I can't emphasize that enough. Always work with Google, because no matter where you go, what you do, anywhere, nothing will be 100% what you need, but working with Google, you can get it to that 100% of what you need, and they will help, and they're actually very, very helpful, from AMs to PMs to TAMs to everyone at Google. They really, really help you drive to where your solution needs to go. And thank you.
Thank you very much.